So, very good morning, students. Welcome to IIT NEET or Focus C program by Krishnavedi Talent Schools and Mastermind Schools. So, once again, I welcome all the class 8 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Today we are going to start chapter number 2, motion in straight line. So today we are to the session number 1, right? So already we completed first chapter, units and dimensions, in the last 3 sessions, 3 days, 3 classes. Today we are entering into the chapter number 2, motion in a straight line. So our life, entire life, when you wake up till you go to the bed, we can see different types of motions, right? Without movement, no work is done. Correct or not? So motion plays very important or very vital role in our day-to-day life. So the motion can be either one-dimensional, it can be either one-dimensional or two-dimensional or three-dimensional. 3 ways. One-dimensional means only one direction. For example, we have X, Y, Z axis. Simple way I am explaining. X-axis, Y-axis, and Z-axis. As you are 8th class students, you can understand. If body travels only along one axis, this is called straight line motion, one-dimensional motion. If your body will travel both X and Y along the direction, it is called two-dimension. All 3, X, Y, Z, that is called 3-dimension. So already we know what is the motion. In lower classes, when you are in 6th and 7th, you learn about what is motion, what are the various types of motions. But in this class, we'll separate them, we'll classify. We are focusing on one dimension in 8th class, 2-dimension in 9th and 10th class. So when you go to the 11th and 12th or intermediate, you can see 3-dimension also. So motion can be of 3 types, either one-dimensional motion, two-dimensional motion, or 3-dimensional motion. The body moves along x-axis. It's called straight line motion. Is called one dimension. Along x and y axis, which is 2-dimension, right? So along x, y, z, all 3 axes, that is called 3-dimensional motion. But in our particular class here today, in a 8th class, next maybe it takes 3 classes to complete the chapter. Within the next 3 classes, we are going to discuss about what is the motion in straight line. Motion in straight line, that is one-dimensional motion, right? So when you see your one-dimensional motion, so first you should know exactly what is the motion. So this is your textbook motion in one dimension, textbook part. So we can find the material, page number 15. We can see there, page number 15, right? So when you see here, introduction part. So motion in one dimension. Objects are in motion everywhere when we look around us. Correct or not? When you see here and there, you can see so many things are moving around us. Everything is from tennis game to the space probe flyby of the planet Neptune involves in motion. You see tennis ball, when you hit the ball continuously from here to there, from there to revolving of the planets, everywhere you can find the motion. Correct? So question about motions are interesting in themselves. There are so many types are there. Okay. So where will the football lands? Through the certain angle. So when you are hitting the football, you can hit along the ground or you can hit with the in air also. But thing is, whether it's going straight line or following any angle, Based on that, either it can be 1 dimension, 2 dimension, or 3 dimension. That means motion also there are, I told already, different way. In one case only, we can find all the 3 dimensions. So our formal study begins with the kinematics. So when you are studying about the motion, first you will come across is kinematics. So what is kinematics? Before going for that, see, in physics, there is a major part of physics is mechanics. The mechanics is the major part of the physics which is discussed about the motion only. Right? A branch of physics which deals with the study of motion. Study of motion. A branch of physics which deals with the study of motion is called mechanics. So this mechanics is classified into 3 categories again. One is kinetics, right? Second one is kinematics. And third one is dynamics. Right? So entire mechanics is completely dealing about the motion only. So as you know, there are different types of motions are studied under different branches. First is kinetics. Kinetics is nothing but study of the body which is at rest. Study of the body which is at rest is called kinetics. So what is rest? When rest is there, what is needed? So there is so many possibilities of the rest. Suppose pen is there. In pen is my hand. It is at rest, right? It is at rest. Correct or not? This can be rest when there is no force is acting on the this one, or many forces are acting. If anybody, for example, you are standing in the classroom center, 2 of your friends are coming and they are pulling you on either side. Those 2 are applying same force. So where you will go? You won't move either that side or this side. You will be at same position. That means you are at rest only because you are not changing the position. Or when you apply the force on 2, your compass box is there with you. Apply force from both sides. Compass box cannot move anywhere. Means when you apply the equal and opposite forces also, body is at rest only. When there is no forces acting also, body is at rest only. So such study of position of a body at rest is called kinetics. What? Kinetics. Right? Second one is kinematics, what you mentioned here. Study of motion of the body. We are not discussing about how body is moving. We are not matter. We are not discussing about the cause of the motion. But what we'll discuss? What is the motion? Whether it may be 1 dimension or 2 dimension or 3 dimension. Study of motion of a body is called without considering the cause. We are not considering cause. Means why moving. Cause is nothing but why body is moving. We are not considering. Third part is dynamics, which is purely study of motion of a body along with cause of motion. Why body is moving. Why body is changing direction. Why body stopped suddenly. There is some cause like force. So study about that cause, that force is called dynamics. Study of rest is kinetics, study of motion is kinematics, and study of cause of motion is dynamics. These are the main 3 major parts of mechanics. Right? Clear? This part you learned already in lower classes. Any of you already recall? So, what you can say here? So, what you can say? Kinematics is the study of motion of a body. Study of motion of a body without considering the cause. Without considering cause. We are not considering what is the cause of motion. But still we are reading about the motion. Okay, that you can note as a very important point. Starting before going for the motion or rest, we have read this. Kinematics, which is defined as study of motion without considering the cause. The word kinematics from some Greek term meaning is motion. The point number 2. Point number one. Point number two. Kinematics, which is defined as the study of motion without considering the cause. What is cause? Why body is moving, we don't want. Whether body is moving or not. If it is moving, what is the direction? And the word kinematics means only motion. In one-dimensional kinematics and two-dimensional kinematics, we study only motion of the football, for example, without worrying about the what force cause or changes motion. Such consideration comes in the other chapters. In this chapter, we examine the simple types of motions, namely motion along straight line or one-dimensional motion or motion in a one-dimension kinematics. Anything you can name. You name anything, it may be one dimension or two dimension, three dimension will come in high classes. What we are discussing today is, this class is only consideration that types of motions, namely whether body is moving along straight line or one dimension motion is also called motion in one dimension kinematics. In kinematics also there is a one dimension, two dimension is there. But today we are discussing only about the one dimension kinematics, that is straight line motion. Okay. So before knowing about the motion, we should know another important word called rest. Because when the body before going motion is resting, because something has happened, it comes under the rest ability. Okay. Oh, I think just a minute. So before going for the study about the motion, first you should know about what is the rest or position. You know all rest. What is rest? Suppose here see a leaning tower of Pisa, Paris. Tower, right? Paris, the reason it's called leaning tower. It is a position only, it's a rest. Why you are calling it is rest? Because it is not moving from so many years. It is not changing its position from so many years. Suppose you are sitting, I am also sitting here. So I am taking the online classes. So as per the physics, I am at rest only. Even though I am doing some work, I am teaching you, I am shouting, I am so many things, I am at rest. Because I am not changing the position. In classroom, teacher will teach. You are teaching on the board. She is not at rest because she moves here and there. Whether she is doing work or not, if she moves here and there, if changes the position, they are called at rest. So before the position, before the motion, body can be either at one position or maybe at rest. Suppose tower is there here. Three persons are seeing ABC from three different positions. So the way of observation is different. One is at east, one is south, one is north, one is west. So that is called the position. Any object situated at point O and three observers are different places are looking for the same object, then all observers will have different observations. So suppose I am teaching online classes. Everybody is not under the same impression that sir is teaching well. Some may be thinking sir is teaching well. Some may be teaching sir is teaching speed. Some may be thinking sir teaching is not understand. That is the way you are thinking. Similarly here also. When a body is at position, when your car is moving from your front of you, when you see that car, you can feel that car is moving. But when the driver inside the car will see you, he'll think that you are moving. That is called the position. That is called frame of reference. From which angle you are seeing the body. That is called position or frame of reference. Okay. So when you move forward, so after knowing about the position, what is next is rest and motion, which is the first important terms in kinematics or first important terms in motion in straight line. So already I told what is rest, you all know. So if your body does not change its position, say point number 3, if the body does not change the position as time passes with respect to surrounding, is said to be at rest. Suppose you kept your textbook on table, physics textbook on table, you forgot to keep in your bag. You forgot there and you went home. Next day when you came back, book is there only. If book is there, the book is said to be at rest. Book is not there, it is motion. Somebody stole it. Means a body is continuously occupying same place for long time. Your school benches are there. Your board is there. Right? Your cycle you kept in the cycle stand. That is there. Your school bus after dropping all the students. They all stay at same time, same place for many time. Time will go, but body is there only. Then we can call it as rest. That is called rest. Suppose, point number 4 you can see. If a body changes its position from time to time with respect to surrounding, is known as body is in motion. When you say body is in motion, when a body changes its position. So then in classroom also there are so many students, they won't sit at one place. They'll change the place from period to period or in between the periods also. They are said to be in motion because they are changing their position. Right? Correct or not? When a body is not changing its position along with respect to time or surroundings, then the body is said to be at rest. If the body changes its position from time to time with respect to surroundings and time, is called motion. These are the two most important terms in motion chapter, or motion in one dimension or two dimension, whatever it may be. The basic terms. Suppose imagine when body is moving. What happens? So there are so many physical factors will come across, physical quantities. When body is at rest, only simply at rest, because it is in the same position for a long time. But when body is changing the position, we can say that body is in motion. You will be seek back and you can find reference, frame of reference means with respect to what you are seeing. So motion is the change in the position of object with respect to time. In order to specify the position, we need to use reference point and set coordinate axis. It is convenient to choose a rectangular coordinate system, 3 mutual perpendicular axes. So just I told us x, y, z, 3 mutually perpendicular like this. You can place fingers like this. They are called a frame of reference. 3 mutually perpendicular x, y, z. X always perpendicular to each other. So the way you are looking at them, looking the object, based on that, we can that position is called frame of reference. What you can call frame of reference with respect to particular person. Just now I told you, a person is watching, a cars are going, or train is going. Okay. X, Y, Z axis, we are referring. So when you are seeing car is moving in front of you, you feel that car is in motion. But a person inside the car feel that you are in motion. That is relative. That is called a reference. Suppose you are traveling by bus. The person who is watching from outside, he feels that you are also traveling with bus. But you are, with respect to bus, with respect to that person, you are traveling. But with respect to bus, you are not traveling because you are sitting in the bus. Correct or not? That is called frame of reference. With respect to which you are defining. That is called frame of reference. Right? Then, so we know what is kinematics. We learn what is motion, what is rest, what is the frame of reference. So before going for some more terminology about this, let us see one video on motion. Then we move to the chapter again. Right? Just see one.
Motion is common to everything in the universe. We walk, run, and ride a bicycle. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to the other. The earth rotates once every 24 hours and revolves around the sun once a year. The sun itself is in motion in the Milky Way,
These all are
which is
different types of
again
motion.
moving within its local group of galaxies. Objectives. At the end of this lesson, you'll be able to understand mechanics and its
What I
classification,
told already.
distinguish between statics and kinematics, distinguish between rest and motion,
Up to here we learned.
understand relative
That we
motion,
can see later.
understand types of motion,
That
define point mass object and frame of reference, differentiate between path length and displacement, differentiate between speed and velocity,
is our total.
mechanics and its classification. All living things move by themselves without any external help. Animals move from one place to another, or they move their body parts, are all motion. The branch of physics which deals with the study of motion of material objects is called mechanics. Mechanics is broadly classified as 1. Statics, 2. Kinematics. Statics and kinematics. Statics. The branch of mechanics which deals with the study of objects at rest is called statics. It is the study of motion of objects under the effect of forces in equilibrium. Time factor plays an important role. Kinematics. The branch of mechanics which deals with the study of motion of objects and the factors which causes motion. The force is the cause of motion. Time factor plays an important
So
role.
we never read about force in
Rest
time.
and motion. Rest. An object is said to be at rest if it does not change its position with time and with respect to its surroundings. When the book lies on the table or a person sitting in a chair shows rest. Motion. An object is said to be in motion if it changes its position with time with respect to its surroundings. A bird flying in air, a ship sailing on water are example for a body in motion. Rest and motion are relative. A person sitting in a moving train is at rest with respect to his fellow passengers, but is in motion with respect to the objects outside the train.
Correct. I just now I told her. The both are sitting in front of them. They feel that they are at rest only. But person who is seeing from by outside, he feels that they are traveling. That is the frame of reference.
This is the situation when object in one situation can be rest, but in another situation the same object is in motion. Hence, rest and motion are relative to each other. Example, a person sitting in his house is at rest, but with respect to Earth, it is in motion with respect to other planets. Types of motion.
So this
Motion
we
is of
discussed. Only
three
we learn in lower
types.
classes
1. Rectilinear motion.
that we are discussing.
When
Straight
body is
line.
moving along a straight line is called
Motion in straight line.
rectilinear motion. 2. Circular motion. When body is moving on a circle, it is called circular motion. 3. Oscillatory motion.
To and
The
fro.
to and fro
Back to
motion
forth.
repeatedly about a fixed point in definite time interval of time is called oscillatory motion.
So these are the three major types. Under them, different types are comes again. Okay. Then already we learn in 6th and 7th classes types of motions. Here we are not come across all these things. These are the basics. When you know about motion, you should know what are the major types of motions. So you can see so many examples for rectilinear motion, so many examples for circular motion, so many examples for even oscillatory motion also. That I would explain you.
Point mass object. An object is a point mass object if during motion in a given time it covers distances much greater than its size. Example, the revolution of Earth around the Sun, the diameter of Earth being very small as compared to the length of the orbit around the Sun, the Earth can be regarded as the point object. Frame of reference.
This is what we
The system of coordinates axes,
X, Y, Z.
three straight lines inclined to each other at right angle, attached to an observer
Mutual.
region with respect to which the observer can describe position, displacement, velocity, acceleration, etc. of a moving object. It consists of three coordinates
X,
Y,
one dimension, two
and
dimension,
Z
three
with
dimension.
origin O at the starting point of the particle. Motion in 1, 2, and 3 dimensions. One-dimensional motion. The motion only in one out of three coordinates
Specific.
specify the position of the object changing with respect to time. Example, car traveling in a straight line. Two-dimensional motion. The motion of an object in 2 out of 3 coordinate specifying the position of object change with respect to time. Example, a billiard ball moving over a billiard table. Three-dimensional motion.
Tight.
The motion of the object, when all the three coordinates are specified, the position of the object change with respect to time. Example, a kite flying on a windy day. Difference between path length and displacement.
This will come across.
Path-
Okay. So this is our next topic. So our next topic is this. So after discussing, we'll discuss, right? So that is about up till now we learned about what is a kinematics, a branch of physics which deals with the motion of a body without considering the cause of motion. We are not discussing here why body is moving, right? So that we discuss. Then we learn about what is rest, what is motion, what is frame of difference. Of course, in motion also one dimension, two dimension, three dimension. Suppose now the next part is because study of motion only, you forget about rest. Rest word you remove from the brain because now we are discussing only about the motion. When a body is moving, either its body may be cycle or two-wheeler, four-wheeler, or yourself, or anything which is moving, it comes across some terminology. When every moving body will have something. It will cover some distance. Distance word comes when the body is in motion, or displacement. Both sound same, but difference is there. Or will come across speed. Moving body will have some speed, or will have some velocity. So both are almost similar, these two. Then it may have acceleration, right? When body moving, acceleration also will be there, right? It takes some time. Time also will run. When a body is moving, it will go, time also will run. So these are the some terms will come across when the body is in motion, or can be retardation, that is decreasing of acceleration. So these are all are the terms related to motion. Why they are called related to motion? Because whenever body is in motion, all these terms will come across. All these terms, either it may be distance, displacement, speed, velocity, acceleration, retardation, and time. So for every moving body, we can see all these physical quantities. So this chapter only related to this, only basic. Learn to know about the terms related to motion. Terms related to motion. So first one is distance. It is defined as length of the actual path followed by a body as it moves. Length of the actual path. Suppose we are starting from A. We move to B. Right? So your house to school. This is called distance. Suppose you are moving another way. This is straight line. Suppose you are going from like this, you go into A to B. So what is actual path? Length of actual path is from A like this. This is totally called actual path. So this entire path is called a distance. Whether body may be moving straight line or it may be moving the any other direction. You can, for example, morning time when you go from home to school, you'll go straight only. Right? You'll go straight. Say it's 2 kilometers from your house to school. But evening when you are going back to home, you visited some house, your friend house, and move like this. Suppose your friend house is there. So this is called the distance. It may maybe 3 kilometers. So this is called displacement. The shortest path. See, in this case, this is the displacement. The shortest path is called displacement. The total path is called distance. So if anybody asks, where is your nose? We'll show like this. This is displacement, shortest. If you show like this, it is the distance. The many examples you can see. The shortest path or distance traveled by a body or actual length of the path is called distance. Okay. See here. Then dimension formula, already we have seen. Length L1, M0, T0, L1 is the length. Length is L1 you can write. And it is measured in meter or centimeters. So see, distance traveled by a body never decreases with time. There is no chance of decreasing, right? The distance traveled by a body can never be negative. It is a scalar quantity. It has only direction, only magnitude, no direction for the distance. That's why it is scalar quantity. Distance cannot be negative. Very important points about the distance. So, distance is defined as actual length of the path. Actual length. You can go to Hyderabad to Vijayawada in straight road also via Kodada, but you can go to Hyderabad to Vijayawada via Khammam also. The shortest path is called displacement. The total path is called distance. That is the only difference. So, when you see the second one, displacement. Magnitude of displacement is the shortest distance between 2 points. The shortest is called, right, the shortest distance A to B. Either you can go directly here, this is called displacement, or you can go like this also. So this is called distance. This is shortest path is called displacement. That is the only difference between but there is a big difference between these two also. Lot of differences you can find. So distance cannot be negative. Displacement can be negative. Right. See, one more important thing is distance is always greater than or equal to displacement. Very important point. How can you say, see, distance, for example, body is moving in straight line. So what is the distance? AB is the distance. Displacement also AB only. Sorry. Distance is equal to displacement also. That's why I wrote greater than or equal to. Distance and displacements are same when body is in straight line. But in other all cases, distance is always greater than displacement. See here, is the distance 2 kilometers? It is 3 kilometers. Distance is always more. Only one case both are same is when a body moves in a straight line, what we are discussing in the today's chapter. So these are the two terms which sound same, but there are a difference between them. Right? Hope you understood. See here. So many examples are given here. Some pictures are given. Here a body displacement shortest distance between the initial and final position. The shortest. Okay. In straight line, when both are same only. So from here, we are going up to factory. So see how they are moving distance. Displacement is a straight line. This dotted line is there, that is displacement. All these 200, something distance are given. Here also see. So that is the difference between the distance and displacement, which are the first pair of terms comes when the body, when your body is in motion. Okay, you can see some more examples are given here. A professor places left and right hand while lecturing. Her position related to earth is given is equal to x. 2 meters displacement of professor related to earth is represented by arrow pointing to the right. See how he is moving. There is a distance is there, displacement is there. Depends on the motion. Different change in the position. So these are the two important terms First, we'll come across when body is in motion. Distance, displacement. Okay. So after that, we'll come across many more like speed, velocity, I told, acceleration, deceleration. So various types of velocities will come across. So that we'll discuss in the next class. Okay. So in next class, we'll all discuss about all these things. Remaining part of the chapter. Okay. So that's all for today. What we learn about kinematics. So very important home task for today is differentiate between rest and motion with examples. Okay. Right. So thank you all of you. Have a wonderful day. Thank you.